Okay, here in this section, we're going to learn how to prove identities the proper way. And so we're going to start with the Pythagorean identity. Cosine squared plus sine squared equals 1. We already know this. Now, what does an identity mean? An identity means basically it's always true no matter what angle you plug in there. So for example, if I did cosine squared of 30 degrees, choosing 30 degrees, plus sine squared of 30 degrees, right? Plugging in 30 degrees in for theta, we know the square means we're going to square cosine of 30 degrees, and that's square root of 3 over 2. Now, when you plug into identity, it should be equal to 1 no matter what, right? And so here we have sine squared, and sine of 30 degrees is 1/2. And so this equals, when you square this, you get 3/4, plus the square of 1/2 is 1/4. And 3/4 plus 1/4 is 4/4, which is equal to 1. And you can see, no matter what angle I plug in there, I'll get a 1. That's what an identity means. It's always true. Now look at this. We can start with the Pythagorean identity, and we can derive more identities from that, simply by dividing here by cosine squared theta, both sides. That's legal. We could break this common denominator up. Well, we could break this fraction up with a common denominator. So cosine squared theta over cosine squared theta, right? Where cosine squared theta is the common denominator. Sine squared theta over cosine squared theta equals 1 over cosine squared theta. Okay, and then here you can see cosine squared cancels, and when that happens you get a 1. So 1 plus sine theta over cosine theta squared, we're squaring both of those, so that's the same as sine over cosine squared, equals 1 over cosine theta squared. Okay, now remember our basic identities, right? So we already know that tangent of theta is sine theta over cosine theta. Okay, you should memorize that. Secant theta is 1 over cosine theta, and cosecant of theta is 1 over sine theta, right? Those are our reciprocal identities that we had before. Okay, so I'm looking at this and I see sine over cosine now. Sine over cosine is really tangent. So this is 1 plus tangent squared theta equals 1 over cosine is secant. So this would be secant theta squared. All right, and that gives us another identity here. 1 plus tangent squared theta equals secant squared theta. So from the Pythagorean identity, we are able to derive another identity. And so if we were to next divide by sine squared on both sides and do the same type of thing, we'll come up with cotangent squared plus 1 equals cosecant squared theta. All right, so these are called the Pythagorean identities. Pretty easy to derive, and we can get that, from the original Pythagorean identity, either dividing by sine squared or cosine squared. Okay, so now let me show you how to do a proof properly here in trigonometry. All right, so here we want to prove that cosine theta is always equal to cotangent theta over cosecant theta. Now, when you're making a proof, I'm not going to accept T-chart proofs. So in this class, the proper mathematical proof starts with one side, you work on it with identities or definitions until you get to the other side. Typically, you want to start with the more complicated side. And so on this one, it seems like I should start with the cotangent over cosecant. Always rewrite the side that you're starting with. All right, so that's the side I'm going to start with, and I'm going to work identities and definitions until I get to cosine theta. That's the plan. All right, so cotangent theta is 1 over tangent. Tangent sine over cosine, so cotangent is cosine theta over sine theta, right? So I'm replacing cotangent. Cosecant is 1 over sine theta, right? And so there's those replacements. And now when you're dividing two fractions, you really multiply by the reciprocal of the denominator. So we'll write cosine theta over sine theta times, the reciprocal of that would be sine theta over 1. Right? The sines cancel, and we're left with cosine theta. So that's the anatomy of a proof. You start with one side, you work definitions or identities until you get to the other side, okay? That's how we're going to make our proofs. Now let's do another one. Okay, now here's another identity, 1 minus cosine squared over cosine theta plus 1. That's supposed to always equal 1 minus cosine theta. All right, so let's prove it. And again, you know, students have trouble with proofs. Rule of thumb is you want to start with the more complicated side and try to do algebra or simplifying as best you can and see where it takes you. You know, sometimes your first try doesn't work out. And you just try something else. Erase it and try something else. So I'm going to start here with the left side. That definitely looks more complicated to me. Cosine theta plus 1. Now, from algebra, I know difference of squares. A squared minus b squared equals, right? That factors difference of squares. A plus b times a minus b. And so that's what we have here, difference of squares. It turns out 1's a perfect square. 1 squared is 1. And cosine squared is a perfect square, obviously. So I'm going to factor this difference of squares. So a plus b, where b is cosine theta, and then a minus b. Okay? So this difference of squares factors like that. That's kind of a common trick. Keep that in mind. All over cosine theta plus 1. Now, since addition is commutative, these two factors are the same. 1 plus cosine theta and cosine theta plus 1 are the same, so they cancel. And what's left here is 1 minus cosine theta. And that's what we were trying to prove. So in this one, we started with the left side. We factored the top, we canceled, and then we got to the right side. All right, that one wasn't so bad. Let's try another one. Okay, here we're asked to prove sine theta minus cosine theta squared as a binomial equals 1 minus 2 sine theta cosine theta. That one looks a little bit complicated. It's really not so bad. When we make our proof here, I'm going to start with this left side. So I'm going to rewrite that. Sine theta minus cosine theta squared. Always rewrite the side you're starting with, okay? So that whoever's reading your proof, they know what you're doing. All right, so I need to work on this until I get to this side. That's the plan. And since I'm squaring, I'm just going to go ahead and use algebra and FOIL this out. So what this really means is sine theta minus cosine theta times itself, sine theta minus cosine theta. All right, that's what the square means. And so when I distribute, I'll have sine squared theta, and then minus sine theta cosine theta. Right? And then this one times this one is minus sine theta cosine theta. And then this one times this one is plus cosine squared theta. Right? So I FOILed that out. And then at this point, I have sine squared theta minus 2 sine theta cosine theta. Right? There's two of these. These are like terms. And then plus cosine squared theta. Okay, now somehow I got to get to 1 minus 2 sine theta cosine theta. All right, so that's not what this is, but we're close because I do notice that these two together, I can make a replacement with the Pythagorean identity because I know cosine squared theta plus sine squared theta equals 1, right? That's the Pythagorean identity. And so these two together, I'll swap out with a 1. So 1 minus 2 sine theta cosine theta. Now you can't subtract these 1 minus 2 because they're not like terms. In any case, that's what we were trying to prove. Right? So all I did was FOIL this out, make the Pythagorean identity replacement, and I made the proof. Awesome. Okay, so now for our last example, it's a little more complicated. Here we have a couple fractions, 1 over 1 minus sine theta minus 1 over 1 plus sine theta equals 2 tangent theta secant theta. Okay, so to make this proof, I'm going to try to start with the left side here. 1 minus sine theta minus 1 over 1 plus sine theta. Okay, so rewriting that side, what I'm going to do is get a common denominator and see where it takes me. So we have two fractions, so to get a common denominator, we need to multiply top and bottom of the first fraction by 1 plus sine theta, and then top and bottom of the second fraction by 1 minus sine theta. Okay, and then we can subtract those two fractions and put it all over the common denominator. All right. So I did a little common denominator going on there. Okay. And then from here, once I get a common denominator, I think, where do I need to go? I need to go here. So I'm going to go ahead and distribute this negative. Certainly I cannot cancel 1 minus sine theta because of that minus right there. So I will distribute it. And also, I'm going to multiply out the bottom here. Okay, so on the top we have 1 plus sine theta minus 1 plus sine theta, distributing the negative 1 there. Now when I distribute out the bottom, I'm going to get a 1 times a 1, and then a negative sine times a 1 is minus sine theta. And then, oops, I'm sorry, 1 times a 1, and then a 1 times sine theta, and then a negative sine theta times 1 is negative sine theta here. And then a negative sine theta times sine theta is negative sine squared theta. Okay, so I distributed out the bottom, I distribute that negative. Let's see what kind of algebra we get from here. So we can see the 1's add to 0. So on the numerator, in the top there, we have 2 sine theta. And then in the denominator here, the sine theta and the minus sine theta add to 0. I'm left with 1 minus sine squared theta. Now, that's not quite where we need to go. We need to go to 2 tangent secant. And I have 2 sine over 1 minus sine squared, so it looks totally different. But let me let you in on a little bit of a secret. If you have the Pythagorean identity, cosine squared plus sine squared theta equals 1, you can derive another identity simply by subtracting sine squared. So then, if I do that, I'll say cosine squared then would be equal to 1 minus sine squared. Okay? And so from the identity, simply by subtracting, I can see that 1 minus sine squared is actually cosine squared. All right, and so I can make that substitution. And I'll have 2 sine theta over right? This is going to get replaced with cosine squared. Okay, now we're getting closer. So we're trying to get to 2 tangent secant. So what I'm going to do is just break this up. We have a 2 in the front, right? We have a couple cosines on the bottom. So that's the same as sine theta over cosine. That's not a common denominator. This is multiplication times cosine theta, right? So there's 2 cosines on the bottom, cosine squared, and then there's a 2 and a sine theta on the top. So if I write it like that, you can really see that this is 2 times tangent times secant, right? 2 times tangent times secant. And that's what we were trying to prove here. All right, so that one was a little more complicated, and there's a few proofs. Now you try a few in the exercises.